Join me as I dive into the mind-bending world of time travel and put the Novikov Self-Consistency Principle to the test. Can I really avoid paradoxes while jumping through time? In this video, we're diving into the Novikov Self-Consistency Principle and how it claims to resolve paradoxes associated with time travel. Time travel is often depicted in media as a thrilling concept, but it raises serious questions about the nature of causality and paradoxes, like the famous grandfather paradox. You know, the one where if you went back in time and killed your own grandfather before he had children, that would mean you were never born. But if you were never born, then who killed your grandfather? It's a mind-bending puzzle that has puzzled physicists and philosophers for decades. But what if I told you there's a solution to this paradox, one that could potentially make time travel possible without messing up the timeline? The Novikov Self-Consistency Principle is one of the most promising approaches to resolving these paradoxes, and today, we're going to explore it in depth. This principle was first proposed by physicist Igor Novikov in the 1980s as a way to reconcile time travel with the laws of physics. So, what exactly does it say? Let's take a closer look at the grandfather paradox again. If we apply the Novikov Self-Consistency Principle, we'd find that it's actually impossible to kill your own grandfather before he had children. Not because you're physically incapable of doing so, but because the timeline wouldn't allow it. The principle states that any events that occur through time travel must be self-consistent with the timeline, meaning they can't create paradoxes. But how does it actually work in practice? We'll delve into the Novikov Self-Consistency Principle, which suggests that any actions taken by a time traveler must be self-consistent with the timeline, preventing paradoxes from occurring. So, let's say you wanted to go back in time and kill your own grandfather. According to the principle, the timeline would prevent you from doing so, perhaps by making you miss your target, or by causing some other event that would prevent the paradox from occurring. The key idea here is that the timeline is self-healing, and it will always find a way to prevent paradoxes from arising. But what does this mean for our understanding of free will and causality? If the timeline is controlling our actions, do we really have a choice in what we do? This principle has some fascinating implications for our understanding of time and causality. If time travel were possible, and the Novikov Self-Consistency Principle held true, it would mean that every event in history is predetermined, and that we're just along for the ride. It's the idea that challenges our traditional notions of free will and moral responsibility. If our actions are predetermined, can we really be held accountable for them? The Novikov Self-Consistency Principle raises more questions than answers, but it's an idea that's worth exploring further. What if we could use this principle to predict the outcomes of our actions and avoid paradoxes altogether? The key moment arises when we discuss real-world implications of this principle and what it would mean for our understanding of time and causality if time travel were possible. Imagine being able to send information back in time, but knowing that the timeline would prevent any paradoxes from occurring. It raises interesting questions about the nature of communication and information transfer through time. Could we use the Novikov Self-Consistency Principle to create a sort of temporal internet, where information is transmitted through time, but always in a way that's self-consistent with the timeline? But what about the potential risks of time travel? If we were to send information or even objects back in time, could we inadvertently create paradoxes or disrupt the timeline in some way? The Novikov Self-Consistency Principle suggests that the timeline would always find a way to prevent paradoxes, but what if it failed? What if we were able to create a paradox that the timeline couldn't resolve? The implications are mind-boggling, and they highlight the need for further research and exploration into the nature of time travel and the Novikov Self-Consistency Principle. To wrap up, we'll summarize how the Novikov Self-Consistency Principle offers a fascinating perspective on time travel and paradoxes, leaving us to ponder the mysteries of time. The principle offers a solution to the grandfather paradox and other time travel conundrums, but it also raises important questions about free will, causality, and the nature of time itself. Whether or not time travel is possible, the Novikov Self-Consistency Principle is a thought-provoking idea that challenges our understanding of the universe. If you enjoyed this exploration of time travel, be sure to check out our other videos on related topics and share your thoughts in the comments below.